Okay, so today I'm going to talk to you about force diagrams, known as free body force diagrams sometimes. So we're going to start with an object. Here is my amazing red truck. So this red truck is going to be a toy car, remote control car or something like that. So the forces involved are quite small. Now we have a forward force provided by the motor or the engine or the spring. Now this is what we're going to call thrust. So this moves the object forward. The amount of force on this one, I'm using the lines on the book, so I'm saying 7 newtons. So it's got 7 newtons of forward thrust. Now an object moving through air is going to produce air resistance, and that goes in the opposite direction to the thrust. So that is an opposing force. And that's shown by the purple, and that is to scale. I've gone for 5 newtons. So the important thing with these arrows is it shows the direction and the magnitude, the amount. So I got 7 going forward, I got 5 going back as air resistance. But don't forget, I got these cute little guys here. That will be friction as a contact force between the wheels and the ground. So there is friction there, only small amount, 1 newton on each. So that gives me a total of 2 newtons of friction and 5 newtons of drag. Another force on any object with a mass that's not in space will be weight, and weight is a force due to gravity, so that is pulling down towards the center of the earth. And let's say this has got a weight of 10 newtons. Now because this vehicle is on the ground, it is not flying and it is not sinking through the floor, there must be an equal and opposite reaction force. Okay, so this is normal reaction force, which is the same force that keeps you from falling through the earth or flying off. And we think that this must be represented by equal arrows, equal and opposite to weight. So for example, that was 10 newtons of weight, and so 5 and 5 on each wheel of normal reaction force should give us a balanced force. Now here's the maths. So I try and work out resultant forces, the overall winner. So I got a weight of 10 newtons. I've got normal reaction force of 10 newtons. Okay, so they are equal and opposite, so I'm going to subtract them from one another. So I'm going to work out who wins overall. So I got 10 down, I got 10 up. So 10 minus 10 newtons equals 0 newtons. So they are balanced forces. The resultant force is 0 with no direction. Now moving forward, I got 7 newtons forward, I got 5 newtons back. So that is unbalanced, that is unequal. 7 forward as thrust, 5 backward as air resistance or drag. So that we know is unbalanced, but don't forget, look at the direction. I got to add on the 2 newtons of friction force. Okay, and that is acting in the same direction as the air resistance. So I've got 7 moving forward as thrust. I've got to take away the 5 because that's an opposing force, but I've added the 2 on there, so I've actually got 7 minus 7 equals 0 newtons. Now here's the careful bit. This car, this vehicle, is moving forwards because it's got thrust at a constant speed, constant velocity.